Dear students, today we are going to discuss RC transient. First of all, what do you mean by transient? The circuit consists of energy storing device. The energy storing device are inductor and capacitor. When the circuit containing energy storing device, if you change the excitation, the voltage and current change from one steady state to another steady state. The behavior of voltage and current change from one steady state to another steady state is called transient state. So the time during the transient state is called transient time. The current during the transient state or transient time is called transient current. So our aim is to find the transient current for this RC circuit. So here we are going to derive a derivation to find the I of t transient current for RC circuit. So before entering into the derivation, you must be very careful. The capacitor is the energy storing device. Sometimes it consists of initial voltage, right? So this point will be useful when you are solving problems. For derivation, we are assuming the initial voltage on the capacitor is equal to 0. If the given initial voltage means you have to take into consideration when you are solving the problem. Similarly, sometimes they will give the initial charge on the capacitor, initial charge Q0. So how will you calculate V0? We need V0 to substitute in the problem. V0 is equal to Q0 divided by C. So that is the formula to calculate V0. So you must be very careful when you are solving the problem. Here, what is the procedure to find I of t? The procedure to find I of t for RL circuit, RC circuit, RLC circuit, whether it is DC or AC, the procedure is the same. First you have to write the Kirchhoff's voltage law equation. Then you have to apply Laplace transform. Then you will get I of S. Then apply partial bracket to separate the term. Then find the value of ABC by using partial bracket you have to find the value of ABC. Substitute the value of ABC in I of S. Then apply Laplace inverse. You will get I of t. So this is the standard procedure whether you are doing derivation or whether you are doing problem. So now we are going to find I of t for this RC circuit. The switch S will be closed at t is equal to 0. We are assuming the initial voltage on the capacitor is equal to 0. So apply Kirchhoff's voltage law, R into I into R plus the voltage across the capacitor in time domain. So already we discussed. So the transient is a time bound. So we must discuss this transient only in time domain. So remaining unit in the circuit theory we are dealing with frequency domain, but transient is concerned because it is a time bound. So we have to find the equation in time domain. Voltage across the inductor or voltage across the capacitor. So you must write in time domain. So here I into R plus voltage across the capacitor in time domain, that is equal to 1 by C integral I dt. So this is the formula to calculate the voltage across the capacitor in time domain. That is equal to applied voltage E plus or minus the initial voltage on the capacitor based on the polarity plus or minus, whether you will get plus or minus. So in the derivation we are assuming this V0 is equal to 0. So we will get I into R is R plus 1 by C integral I dt is equal to E. Then apply Laplace transformation. So R into I of S plus 1 by C into I of S divided by S. So the Laplace transform of integral I dt, that is equal to I of S divided by S. The Laplace transform of integral I dt is what? I of S divided by S, that is equal to E by S, because E into 1, Laplace transform of 1 is equal to 1 by S. Then you find I of S. You will get R plus 1 by Cs, that is equal to E by S. From this I of S is going to cross multiply E divided by S into R plus 1 by Cs. Then you multiply with S. So S into R plus 1 by C. Right? In the denominator you will get S into R plus 1 by C. So E divided by S into R plus 1 by C. So we need the denominator in the form of S plus A. Then only it is easy to apply Laplace transform. So what we have to take out? So from the denominator we have to take R outside. So if you take R outside, so the denominator is S plus 1 by RC. So I of S is equal to E divided by R into S plus 1 by RC. So here, whether it is required to apply partial fraction, it is not required because it is S plus A, S plus B. So it is not the form in the denominator. It consists of only S plus A. So only one term is there. So no need to apply partial fraction. If 2 or 3 terms in the denominator is there, means you have to go for partial fraction. Here no need to apply partial fraction. You have to go directly Laplace inverse. So Laplace inverse of I of S E by R into Laplace inverse of 1 by S plus 1 by RC. So I of t is equal to Laplace inverse of I of S is equal to I of t. That is equal to E by R into Laplace inverse of 1 by S plus A. You know that E power minus AT. So E power, so what is the value of A here? 1 by RC. So E power minus 1 by RC into t. So this is the formula to calculate I of t. Similarly, so here sometimes in the problem they will ask what is the voltage across the resistor at transient? What is the voltage across the capacitor at transient? So what is the voltage across the resistor? You know that I into R. That means R into I of t. I is nothing but transient current. So R into I of t. What is I of t? E by R into E power minus 1 by RC into t. So if you substitute this, you will get voltage across the resistor at transient. That is very important. That is equal to E into E power minus t divided by RC. So this is the expression to calculate the voltage across the resistor at transient. Simultaneously or similarly, so we have to find the voltage across the capacitor. That is equal to EC, voltage across the capacitor at transient. So EC is equal to 1 by C, you know that, integral I dt. So here to calculate, so derive the derivation, we have to use the limit 0 to t, I of t into dt. So C is equal to 1 by C integral 0 to t, I of t. Instead of I, because I of t, I is nothing but transient current. So we are using I of t into dt. So we know that EC is equal to, so if you substitute I of t here, then E divided by CR into 0 to t, so integral 0 to t, the limit E power minus t divided by RC into dt. If you integrate and substitute the limit, finally you will get EC is equal to E into 1 minus E power minus t divided by RC. So this is the expression to calculate the voltage across the capacitor at transient. That is very important. EC is equal to E into 1 minus E power minus t divided by RC. So in the problem they will ask, so find the transient current. What is the voltage across the capacitor at transient? What is the voltage across the resistor at transient? What is the power? So we can, by using this formula, you can calculate. Similarly, so next we are going to deal transient in AC RC circuit. So what is the difference between DC and AC means? The difference is only the voltage. There we are using DC voltage, here we are using AC voltage. That's the only difference. The procedure, everything is same. So here what is the voltage? AC voltage is Vm sin omega t. Similar to previous derivation, you have to apply Kirchhoff's voltage law, you write the equation. So I into R plus 1 by C integral I dt voltage across the capacitor, that is equal to applied voltage, that is the Vm sin omega t plus or minus the initial voltage on the capacitor. That is also very important when you are solving problem. Here we are assuming derivation, we are assuming the initial voltage we are taken as 0. So here there is no initial voltage on the capacitor. Then apply Laplace transform. Right, you will get R into I of S plus 1 by C. Laplace transform of integral I dt is I of S divided by S, that is equal to Vm. So Laplace transform of sin omega t. So omega divided by S square plus omega square. So that is equal to, if you take I of S outside, so R plus 1 by Cs, that is equal to Vm omega divided by, the denominator we can write S square minus J square omega square, because we know the formula for A square minus B square. So for that what we are doing, we are rewriting like this, S square minus J omega square. Both are same. J square is equal to minus 1. Then we will get S square plus omega square, we will get S square plus omega square. Then I of S, so bring this term in the numerator. Then here in this term you take LCM, because we need S plus A form. So for that you have to take a LCM for this term alone, not whole. You take LCM for this. Then you take RC outside. So this you take to numerator, CS you take to numerator, then RC outside. So this CC get cancelled. Then finally I of S is equal to Vm omega S divided by R divided by, you apply A square minus B square, S plus the omega, S minus the omega plus S plus 1 by RC. Then you have to go for partial fraction. Apply partial fraction. I of S is equal to A divided by S plus the omega plus B divided by S minus the omega, C divided by S plus 1 by RC. You find the value of ABC. So whatever method you know. So previous video we discussed a method. A is equal to this I of S into denominator of A and denominator of A is equal to 0. You can use this method or whatever method you know. Find the value of ABC. Substitute the value of ABC. I am not substituting, not finding the value of ABC. You find the value of ABC and substitute here. Then apply Laplace inverse. You will get I of t. So this is the expression for I of t. So here you must substitute the value of ABC. You have to find the value of ABC. A into e power minus j omega t plus B into e power minus j omega t plus C into e power minus 1 by RC into t. So this is the expression for I of t. So here what you have to do is you have to find the value of ABC. You substitute the value, then apply partial fraction. In this I am not calculating the value of ABC. You try find the value of ABC and substitute here, then apply Laplace inverse, then you will get I of t for AC circuit.